Good morning, honorable judges and fellow participants. My name is Soon Fei, and I am honored to be here today. Today, I am excited to present my project, Lib-Genie, AI-powered research navigator.
The core concept of Lib-Genie is to modernize the university library experience. Traditionally, students spend significant time manually filtering through catalogs. Lib-Genie uses natural language processing to act as a T1403507 digital librarian. It doesn't just search for keywords, it understands the intent of the research, provides instant book summaries, and creates a personalized study roadmap for the student. The core concept of Lib-Genie is to bridge the gap between traditional physical library resources and modern generative AI. Hybrid search. Unlike standard search engines, Lib-Genie performs a dual-layer search. It queries a local physical inventory for real-world locations, while simultaneously using AI global knowledge to provide research guidance. Academic authority. The UI utilizes a solid Oxford blue design, avoiding flashy trends to focus on stability, institutional trust, and high readability. Semantic guardrails. The system is designed with strict filtering logic, ensuring that local database results are only displayed when they truly match the user's research intent, preventing misinformation.
Input task. The user provides a research topic through a web interface built on the Streamlit framework. Database task. The system connects to a library database, stored in a spreadsheet format, to retrieve book records. AI task. The core logic is powered by the Grok Llama 3.1 API, which handles semantic processing to match user intent with the database. GUI task. The final results are rendered back to the user as a visual output on the website. The provided flowchart illustrates the operational logic of the Lib-Genie AI Navigator system. Here is a step-by-step explanation of the process. Start. The process begins when the user accesses the system. Input. The user enters a research topic, or a specific keyword, e.g. program, or food. AI processing. The system uses artificial intelligence to analyze and understand the user's input. Search database. Matching with library catalog. The AI cross-references the input with the physical library's internal database. Decision path. Match versus mismatch. Match. If relevant books are found in the catalog, the system proceeds to generate results. Mismatch. No books found. If no direct match is found, the system informs the user and may suggest refining the query, eventually looping back to the input stage. Intelligence generation. Once a match is confirmed, the AI compiles a list of relevant recommendations, based on its semantic understanding of the topic. Execution results. The final output is displayed to the user, including the book titles, their specific shelf locations, and a customized study plan. End. The process concludes once the information is delivered to the user. Development process and implementation. I developed this application using Python as the core programming language, integrated with the Streamlit framework to build a modern, responsive web interface. The source code was written and managed using Sublime Text, with technical assistance provided by GENIEAI for logic optimization. The system architecture follows a decoupled data approach. Database management. The application utilizes externalized Excel files, XLSX, to manage both the library inventory and user credentials. Authentication. User access is controlled via a dedicated database containing authorized usernames and passwords. Execution. The program is executed through the command prompt, CMD, by running the Streamlit server. System workflow and AI demonstration. The following section describes the step-by-step operational process of the Lib-Genie AI Navigator. 1. Authentication phase. Login. Before accessing the research tools, the user must first authenticate through the login portal. The system validates the entered credentials against the username.xlsx database to ensure secure and authorized access. Research prompting. Input. Once logged in, the user enters the Chat Navigator interface. Here, the user can type a research prompt or a specific book topic they are looking for. 3. Hybrid database search and AI filtering. The system uses Grok Llama 3.1 to process the input and perform a semantic search. CASA. Match found. If the topic exists in our database_buku.xlsx, the system immediately displays a structured table containing the book title, author, and shelf location. It provides professional advice and suggests related research keywords, or external resources to guide the student's study path. Case B, no match, strict filtering. If the user searches for a topic that is not in our database, e.g., searching for food in an it-focused catalog, the system is programmed to recognize the mismatch. 4. Intelligent AI response, external knowledge. In the event that no physical books are found, case B, the system will not display any irrelevant data from the database. Instead, it triggers the librarian response mode. The AI utilizes its own global knowledge to explain the topic to the user. It provides professional advice and suggests related research keywords or external resources to guide the student's study path. The system successfully processes a variety of research scenarios. Exact match. Searching for Python returns a structured table with books like Python Crash Course and their exact shelf locations. Semantic match. Searching for coding best practices intelligently recommends clean code and the pragmatic programmer, even without the word coding in the title. External knowledge. Searching for nutrition, not in the IT catalog, triggers the AI guidance mode, providing a nutritionist perspective and external research tips, instead of showing irrelevant library data. Project conclusion. Lib-GeniEai Navigator. The development of Lib-GeniEai Navigator marks a significant step forward in modernizing academic resource management. By successfully integrating physical library data with large-scale artificial intelligence, the project solves the long-standing issue of information fragmentation within university libraries. Key achievements. Seamless hybrid intelligence. The system successfully balances local data integrity, Excel-based inventory, with global AI reasoning, Grok Llama 3.1. It ensures that users receive precise physical locations, shelf IDs, while benefiting from deep contextual explanations. User-centric design. Through multiple iterations, the project achieved a premium solid UI that is both professional and highly functional, prioritizing scannable results through structured tables. Robust semantic filtering. The implementation of strict search prevents misinformation, ensuring that the AI only suggests physical books when they are truly relevant to the research topic. Scalable architecture. The use of externalized databases for both authentication and cataloging makes Lib-Genie a highly portable and scalable solution, ready for deployment across larger institutional networks. Final impact. Lib-Genie transforms the library from a passive storage space into an active research partner. It empowers students to navigate complex academic subjects with confidence, providing them not just with a book, but with a structured path toward mastery.